Okay, welcome along to the June 2023 Paper 2 Calculator paper. We'll go through this video in interludes again like the previous one, so in like 20-minute sections. So what time is it? So, okay, let's get into it. You can use a calculator again. Question 1, you want to solve this equation. Now, you want to get rid of the fractions, that's never good, so let's just go and get rid of that dividing by 2 by timesing everything by 2, because then the 2 here will cancel out. And then similarly with that 3D take away 7, that's not very useful, so to get rid of that, we're going to go and also times through by 3D take away 7. We're just going to go and do it all in one go to save a little bit of time. So that's going to leave us with, on the left-hand side, we're going to have 2 lots of 8D take away 3 being equal to 5 lots of 3D take away 7. And then just going to expand the bracket. So 2 times 8D is going to give you 16D take away 6 being equal to 15D take away 35. And then let's go and get the 15D onto the left-hand side by taking it away. So D is going to be equal to, let's go and add the 6 onto this side to give you minus 29. And that's your first answer. Okay, we're going to check the mark scheme. But yeah, we're all good. Perfect. Question 1 is done. Question 2, you've got the first 4 terms of a linear sequence is given by this here. So linear, it should be increasing by the same number each time. Let's just go and double check that. So going up by plus 3.5 here, plus 3.5, yeah, by plus 3.5. Good. Now to show a plus 3.5 increase in terms of n, you can write this as 3.5n. That's just going to be your 3.5 times table, as you can see over here. Now the issue is, right, 3.5n produces this sequence. You want the one above, which is actually going to be 3.5 to 15 is a 11.5 increase, isn't it? That's an 11.5 increase. So you're increasing every time by plus 11.5. So the overwhelming term is going to be 3.5n plus 11.5. Part A, that should be good. We'll check it in a second. And then part B, you've got a different linear sequence as given by this nth term. Work out the first value, the first negative value in a sequence. This will first go negative when 318 take away 9n is less than 0. So you're now just going to solve the equation, basically, the inequality, sorry. There we go, put 9n on this side, and divide through by 9, okay. Actually, I'm just going to write this as 9n greater than 318. They mean the same thing, I've just written it, switched around. Now, to go and get n, we're going to go and do 318 divided by 9, which will probably give me some decimal. Okay, so I can go and say that n must be bigger than. Let's just whack this into the calculator and see what I get. And I get 35.3 recurring. Now, basically, right, if I go and put 35 into this nth term, it's probably, well, it will just be above 0. It's going to be positive. So the first time it will go negative is when n is going to be bigger than 35.323. So when n is going to be equal to 36. So my 36th term should make this go negative, and you've got to go and plug this in to work out the value. So that's just going to go and be 318 take away 9 times by 36. So 318, 9 times by 36 is 324, I think, which gives you minus 6. Yeah, so that should be the answer. We're going to go and double check the mark schemes, but I think that's looking good. I think we're looking good there. So what we're on question 2A and 2B, minus 6, good, and then perfect. Yeah, we're looking good. Excellent. Okay, question 3. We've got a, my mic's fallen over. We've got a matrix. Now, work out the values of t and u. So these two, you want to multiply out this matrix. Now you've got a 2 by 2 with a 2 by 1. Just go and times it out. So it will go and end up being a 2 by 1 matrix. Now when you times matrices, you're going to do the first row with the first column. So you go and do 3 times 1, which is 3, add 5 times 4, which is 20. So it's going to be 3 add 20 as the top number. And then you go and do the second row with the first column. So u times 1 is u, plus 2 times 4, which is 8. So it's going to be u plus 8 on the bottom. And that's going to be equal to t and then 6. And then just go and simplify the first bit. So 23 u plus 8 must be equal to t and then 6. So by comparing the numbers now, you can go and see that 23 must be t. So that one's nice and straightforward. T is 23. And you've got an equation here, the bottom one, which we go and highlight it. You've got u plus 8 is going to be t. So you can go and say or u plus 8 must be equal to 6, sorry, so u must be equal to minus 2. And they should be the answers. Question 3, minus 2 and 23, we're looking good. Perfect. Okay, question 4, you've got looks like a line question. A line passes through these 2 points here. Now just go and visualize this by sketching it straight away. So you've got point P, doesn't even matter what it looks like, it's just a sketch. Point P is 1K, and then Q, somewhere down here, is R6. Now I do these videos off the cusp, I'm not looking at anything beforehand, just to show you my thinking when I see the question. So honestly, I don't go and read the whole question, I'm just literally picking out what I need straight away. I then look for keywords like, it tells me that the midpoint of PQ has an x coordinate of 5, so I know that the midpoint, let's go and call it mid, of the x coordinate is 5, and that could be useful, well it will be useful, and then the gradient of the line is 2, so that's also very useful, so the gradient is 2, so also I know that m, which is equal to 2. Now to get the midpoint of points, and we're just looking at the x coordinate here, so we're going to be looking at r and 1, you just go and add the x coordinates together, and you halve them. So to look at the midpoint, we're just going to go and take r plus the 1, and you half it, okay, to get the midpoint, and we know that's equal to 5. Okay, so you've got an equation here, which you can solve by times 3 by 2, so r plus 1 will be equal to 10, therefore r must be equal to 9. That's the value of r, you want the value of, you want the value of k, so go and put r, well, we need to go and get another equation, don't we? So we can do that because the gradient is 2, and to get the gradient between 2 points, it's the change in the y coordinates, so let's go and say that m, the gradient, is going to be equal to change in y, so k take away 6 over the change in x, which is 1 take away r, and r is 9. And actually I know that the gradient m is equal to 2, so I can go and put 2 in here, and just go and kind of go and work through this. So k take away 6 over negative 8, and then times through by negative 8, so minus 16 is k take away 6, and then add on the 6, so k must be equal to minus 10. Okay, and if I made no mistakes there, check the mark scheme. Minus 10, we're looking good. Okay, so there we go. I think we'll do a few more. Yeah, we should be good for a few more. What time is that? I've been going for 5 minutes. Okay, well, question 5. Making good progress. Work out the value of x for which the rate of change, now this is a key word here, rate of change means derivative, means differentiation. So you want to go and take the dy by dx of this question. So work out the value of x, of y to x is 7.5. Okay, so basically, right, differentiate your function. Okay, so you're going to go and take that 4 times it through by 0.5, which is 2. X, you reduce the power by 1, and you know that this is equal to 6.75. And then you've got to go and solve this equation. So we're going to go and say that x cubed is going to be equal to 6.75 divided by 2. So x cubed, or x is going to be equal to the cube root of that. That's going to put that into my calculator, which I haven't got open, which is a little bit silly. Where's my calculator? There it is. So we've got to go and do the cube root of 6.75 over 2. What am I doing? Sorry, I'm using a... Okay, which I think... Oh, no. What's happened there? Right, sorry. I'm not using my calculator. I left it at school, so I've got to do it on my phone, which is a bit of a pain. So it's going to take a bit longer, sorry. So 6.75... Sorry, guys, a little bit slow this bit. Over 2. 1.5. Okay, there we go. Works out quite nicely. And that should be the answer. Looking at the mark scheme. It is 1.5. Yeah, it is. There we go. So that's equal to 1.5 if you go and do 6.75 over 2, 1.5. Excellent. Good. Question 6 looks like an equation of a circle. So this here is the equation of a circle. And there you go, right, complete the statements. You want the centre. The centre for the x, you just flip the signs. So that's going to be minus 7, and for y it's going to be plus 4. So it's going to be, the x coordinate will be minus 7, and the y is going to be plus 4. You just flip the signs. And the radius, well, this here is r squared. Okay, that's always the equation of a circle, so r must be the root of that, which is 6. Good. Question 7. Is this here? A sketch of the curve. Okay, there we go. So quadratic in the quadratic form. and it intersects the x at -4 and p, and the turning point is 0.5. Now the turning point is the lowest possible point on the graph, and that's 0.5 as you can see on there. Work out the value of p. Now because of symmetry, right, this turning point is exactly in the middle of the quadratic, so you can kind of think, well, the distance from -4 to 0.5, that is a distance of 4.5, isn't it? So that's going to be sort of like 4.5 across. So to get from 0.5 to p, you go and add on 4.5 again, which should just be 5. So the working there was 0.5 add 4.5, which is 5. And then you want to solve this here. So ax squared plus bx plus c must be greater than 0. Okay. Now, what am I thinking here? What am I thinking here to solve this? Oh, sorry, what am I doing? Right, being really silly here. Right, to solve this, you're saying, right, bigger than 0, you want where the graph is above 0. So this part over here and above this part over here. So you want everything on this side, everything on this side. Okay, so that's when x is going to be less than -4. We'll give you the bits that are bigger than 0. So where x is going to be less than -4. And also when x is going to be greater than the value of p, which you've just found, which is 5. Okay, so, and these are two separate regions, so you've got two separate inequalities. So x less than -4, and you've also got x being bigger than 5. And they should be your answers. Let's just double check that one. But that should be fine. Question 7. So we've got 5, good. X less than -4, bigger than 5, perfect. We're looking good. And we're going to keep going. Question 8, you've got this triangle here, okay, and you've got the area of ABC, which is the big triangle, 25 cm squared. BD to DC, so that's this one to this one, is in ratio 2 to 3. Now it's always good with these kind of questions. This is like 2 parts, and this is 3 parts, but it's 2 parts out of a total of 5, and out of a total of 5, because 2 and 3 is 5. That's usually going to be quite useful. And the area of ABC is 25 cm squared, right? Okay, so that means that the base, which I don't know what this is, I'm just going to call that x, and it's a right angle triangle, so the base x times by the height, which is 4, and you half it because it's a right angle triangle. So I've just done the area of this triangle here, must be equal to 25. So 2x was going to be 25, therefore x must be equal to 12.5. So you now know that this length here, okay, the whole thing is 12.5, and 2/5 of 12.5 is 5, because 1/5 is 2.5, so 2/5 is going to be equal to a length of 5. Okay, so that's got a length equal to 5, which must mean that's going to be equal to 7.5. So 5 and 7.5 gives you the whole 12.5, which makes sense. And that's going to be useful. Now I want to go and work out W. This should be fine now. So I've got a right angle triangle here. And if I want to go and make it really clear to you guys, let's just go and sketch it over here. So I've got this triangle where I know that this is angle W, this is 4, and this side here is 7.5. SOHCAHTOA, okay? And it's going to be tan, isn't it? Because you've got the opposite side with the adjacent. So you can go and say that tan of W is going to be equal to the opposite side, which is 4 over 7.5. So W is going to be tan inverse 4 over 7.5, which equals to whatever it equals to. I've got to use my terrible calculator again, so this could be a bit painful. So let's clear this. Let's clear that. Shift. It also makes a really useful sound, 4 over 7.5, which is 28. Any rounding notes? So I'm just going to go and put 28 degrees, and that should be good. 28 degrees, and there we go. Check the mark scheme. Yeah, it's got a range of values, but that's fine. Correct. Good. Question 9. Let's just continue with this one here. You've got a cuboid, okay, with these lengths here. The total length of the 12 edges is 300. Show that y is this. Now, when we think about this, right, the total length of the edges, so you've got this edge, which is 3x. That's also 3x. That's also going to be 3x. That's also going to be equal to 3x. You've got 4 sides which have a length of 3x, first of all. You've also got some sides that have a length of of 2x, this one, this one, this one, and this one. Again, so you've got 4 lots of 2x on this bit, and then you've also got this part here, this part here, this part here, this part here, which is x plus 2y. So you've got 4 lots of x plus 2y is going to be equal to 300. They're the lengths added together. Now let's just go and expand the bracket. So 12x plus 8x plus 4x plus 8y is going to be equal to 300. And hopefully we just kind of go and rearrange this and simplify it with wider subjects. You're going to get this. Now 12x at 8x, 20x, 24x. So you've got 24x plus 8y is equal to 300. So go and take away 24x. So 8y is going to be equal to 300. Take away 24x, divide through by 8. So you can have 300 minus 24x over 8. Now I can see here this is going to work out nicely. If I divide through by 4, we're going to get this. So if I just go and divide all of these parts here by 4, okay, that's going to go, let's go and write this out, divide by 4. That's going to go to, 300 divided by 4 is 75. That's going to go to 6, and that's going to go to 2. So there you go. Right, it does work out. You get y is equal to 75, take away 6x over 2, as required in the question. Okay, so I've proven that's what the lengths add up to in terms of y. And then part B is the volume of the cuboid is V. Show that V is equal to this thing over here. Okay, so to get the volume, you just times everything together, don't you? So you're just going to go and do, let's go and write this over here. So the volume is going to be equal to 3x times by 2x times by x plus 2y. And you can see here in the question, there's no y in this here. I've got y here, but I'm going to be substituting in this for y. So I can now just go and put in this y value, so this stuff in here, in for this y. So then the whole thing will be in terms of x. So v is going to be equal to 6x squared times by x plus 2 lots of 75, take away 6x over 2. Okay, which is written a bit weirdly, isn't it? Close that bracket. So v is going to be equal to 6x squared times it by x, and then if I times that by, actually these twos will cancel, that's nice. So I've just got plus 75 minus 6x. I hope I'm not making any mistakes here. No, I think it's fine. V is equal to 6x squared, and then minus 5x, or 75 minus 5x. By simplifying, this will work out nicely. So v is going to be equal to, times up the bracket, so 6 times by 75 does give me 450. Good. And it's going to go to just x squared. And 6x squared times by minus 5 is indeed minus 30x cubed. Yeah, which is exactly what I wanted in the question. I've proven this. There we go. So as required. Okay, and then part C is saying use calculus to work out the maximum value of v as x varies. Now, maximum values is all about differentiation, and a maximum, right, which basically is just sort of saying you want like the very top part, that's when the gradient is 0. So that's when dy by dx is equal to 0. So you're going to go and differentiate because you want the maximum volume, so you differentiate dv with respect to x, okay? So you're differentiating this thing up here. Now if you do that, times the 450 by 2, you're going to get 900x, take away 90x squared. And the maximum will be when that's equal to 0. So you've got to go and solve this. Now I'm actually going to go and get the 90x squared onto the other side and take away the 900x. I'm just rearranging it a little bit. Now I'm going to go and factorize out a 90 and an x. So I'm going to get x take away 10 being equal to 0. So either the maximum is going to be when, let's go and do it in a different color, when 90x equals to 0, which is just going to be when x equals to 0, or when x take away 10 is equal to 0, therefore x must be equal to 10. Okay, now it's not going to be 0, so let's go and look at the x being equal to 10. And you've got to go and put it into the volume to get the maximum volume here. Right, so the volume is going to be 450 times by the x squared value, take away 30 times by 10 cubed. Hopefully this will work out nicely. So that's going to be 10 squared is 100, so it's going to be 45,000. Take away 1,000 times by 30, which is 30,000. And if you take that away, you're going to be getting 15,000. Yeah, hopefully that's going to be good. 15,000, I think, should be good. And let's check the mark scheme for this one. 9C. 9C. 9V. Yeah, 15,000. Okay, good. There we go. Good stuff. We're going to leave it there for this part of the video because that's quite a long video already. And I also need to stretch out a little bit, but that's the first part. We'll go on to question 10 on the next video. Good stuff.